Hello everyone. In the previous video, we had seen what is Bayes theorem, right? Basically about inverse probabilities. So in this session, we'll see some of the applications of how do we use that Bayes theorem, right? So let's go into this question number 16. The probabilities that three different persons, Arvind, Anand, and Akhil, will become vice president of a company are 0.4, 0.35, and 0.25 respectively. Okay. The probabilities that they will introduce new product on becoming VP are 0.1, 0.15, and 0.2 respectively. What is the probability that Anand introduced a new product? So one thing we can understand from the question is that a person gets an authority to introduce a new product only after becoming a VP. That is what here it indirectly it means. They will introduce new product on becoming VP, which means they get the authority to introduce a new product only on becoming a vice president, right? So let's understand first and convert that into notations. First one, probability that Arvind, Anand, and Akhil will become VP. So let me define some events. Let A1 equal to event of Arvind becomes VP. Then A2 equal to event of Anand, or I should say becoming Anand becoming VP. Then A3 is the event of Akhil becoming vice president. Now we have been given probabilities of these. So let's write that. Probability of A1 is known to be 0.4. Probability of A2 is known to be 0.35. Probability of A3 is known to be 0.25. It's quite natural that if one person becomes a vice president, other cannot become, right? Because they didn't specify here about a department, they said about the company. So in a company, in one company, there can be one vice president. That is the understanding from this question. And that means what? If A1 happens, it prevents A2 and A3 to happen. Or if A2 happens, it prevents A1 and A3 to happen. Similarly, if A3 happens, it prevents A1 and A2 to happen. That means I can say clearly here A1, A2 and A3 are mutually exclusive. Mutually exclusive. Because it satisfies that mutually exclusive events definition. Now let me add these three probabilities. I will get 1. That means these are the only possible events or only possible outcomes which can happen. Means these are the probable candidates to become a VP. So I can also add these A1, A2, A3 are mutually exclusive and exhaustive. Now, let's continue in the next page. So we have this information with us. Then further it says the probability that they will introduce a new product. That means I have to define one more event, a common event. For all events A1, A2 and A3, we have a common event of them introducing a new product. Let me call that common event as capital B. What is that? Introducing a new product, NP. So now let us go back. What is the question says? The probabilities that they will introduce, they means Arvind, Anand, Akhil will introduce new product on becoming VP. Means the question is given as given probability of B, I mean introducing a new product, given that first person, that is Arvind, becomes a VP, that means it is nothing but A1, that is given as 0.1. So 0.1 means if this condition happens, what is the probability of this? That means if this person, Arvind, becomes a vice president, what is the probability of him introducing a new product? That is given. Then similarly, probability of B given A2 is given as what? It's given as 0.15. Then probability of B given A3 is also given as what? 0.2. 0.2. Now, with all this information, what is the question? What is the probability that Anand introduced a new product? Already we said that these people get authority for introducing a new product only if they becomes a VP, right? So probability that Anand introduced a new product, if you look into this, introduced, that has already happened, means past tense. I will put it like Anand means it is actually A2. So we are supposed to find what is probability of A2 given that new product is already introduced. So for this, we will apply Bayes theorem, so formula which we had seen in the previous video, which is nothing but probability of A2 multiplied by probability of B given A2. And then this whole thing, we will have all those events also, means A1 multiplied by probability of B given A1 plus probability of A2 multiplied by probability of B given A2 plus probability of A3 multiplied by probability of B given A3. Now it is a matter of substitution only. Probability of A2, what is that? A2 is 0.35, so 0.35 multiplied by B given A2, it is known to be 0.15. Then probability of A1, that is known to be 0.4. Then B given A1, it is 0.1 plus probability of A2, it is 0.35. Probability of B given A2, 0.15 plus probability of A3, that is given as 0.25. B given A3, it is known to be 0.2. So if we calculate all this, we may get the end result as 0.37. So that becomes the desired probability, right? So this is whatever here I had used, it is the application of the formula of Bayes theorem. Right. Right. Let us move on to the next question. Here, the probability that a football player will play in an ordinary ground is 0.6 and in a green turf is 0.4. So one thing is clear. Let me define two events. Let A1 equal to event of a player playing in an ordinary ground. then let A2 is equal to event of a player playing in a green turf. So if a particular player plays in ordinary ground, that prevents him to play in a green turf. Or if he plays in a green turf, it prevents him to play in a ordinary ground. So I can say clearly A1 and A2 are mutually exclusive. Then we had also been given about the probabilities. Given, this is given, probability of A1 is known to be 0.6. Probability of A2 is known to be 0.4. So if I add these two, that works out to 1. That means these two are the only two events are mutually exclusive and exhaustive. So I can conclude it is those two events are exhaustive also. Now, what else is given? The probability that he will get, means the player will get a knee injury when playing in an ordinary ground is so and so, and in a green turf it is so and so. That means getting a knee injury is common in both the events. So here the common event, here the common event, comma, B is what? Getting a knee injury. That is possible in both the grounds. Let us continue this in next page. Now, what is given? The probability that he will get a knee injury means probability of B. So this I will say given probability of B, then when playing in ordinary ground, when playing in ordinary ground is nothing but A1. So B given A1 is known to be 0.07. B given A1 is known to be 0.07. Same way, B given A2 is also given. What is that given? It is given as 0.4. 0.4. Now, what is the question asked? What is the probability that he had a knee injury? This has already happened. Knee injury is already happened. That means B has already happened. Now we have to find the probability of playing in that player played in a ordinary ground. So that means probability of what? Ordinary ground is nothing but A1. So probability of A1 given that knee injury has already happened. That is what we have to find. Again, we will apply the Bayes theorem formula. Probability of A1 multiplied by probability of B given A1. Denominator, probability of A1 multiplied by probability of B given A1 plus the other possibility, probability of A2 multiplied by probability of B given A2. So now it is a matter of substitution. What is probability of A1? It is 0.6. B given A1 is 0.07 divided by 0.6 into 0.07 plus probability of A2, we know it is 0.4. B given A2 is known to be 0.4. So if I substitute all these values, and then the probability will work out to 21 divided by 101, or if I do that further, it is 0.2079, or I will round it off to 0.21. That is the required probability, right? So this ends this particular session, and in subsequent videos we will see some more problems where we can apply Bayes theorem. In case if you find this find the contents of this video to be useful to you, I request you to like, share, and subscribe to my channel so that you get regular updates on whatever I am uploading. Thanks a lot. See you.